Yesterday we went through an introduction to polar coordinates and we learned how to convert a rectangular or an XY coordinate, this form, XY, into a polar coordinate, which is r theta. And we had two formulas that we used. R was the square root of x squared plus y squared, and theta is the tangent inverse of y over x. So I just started off today with a review of two of those problems to kind of go through that process again. A lot of people ask, do I need to have my calculator in radians and degrees? Well, as we're working through here, you should find that it's not going to matter. In fact, it's better to put your calculator back in degrees for your final, but because most of the things that, not most, all of the things that we're going to be working with are families that we know. So we'll be able to evaluate the tangent inverse without actually having to calculate a tangent inverse. So when I run through this again, my r would be 0 squared plus negative 2 squared. Anytime you square a negative becomes positive, obviously, so that's the square root of 4, so my r is 2. Now I know it could be plus and minus 2, but we're going to just use the positive radius for today's work. When I do a tangent inverse, this is really saying I need to find when the angle is that value, and in this particular case, negative 2 over 0, it's when is the tangent undefined. And the tangent is undefined when we put the sine over the cosine. When we put the sine over the cosine and the cosine equals 0. So when the cosine equals 0, now if I think about where that happens, the cosine is 0 up here at pi over 2, and down here on the bottom, the lower end of the y-axis at 3 pi over 2. And so if I'm going to try and figure out which of these angles, because I only want to pick one of them for my point, I'm not going to pick both of them, I want to figure out which one I'm going to use, I have to go back to the original point and figure out where, if I were going to graph 0, negative 2, where would that be? Well, that would be down here on the lower end of the y-axis, so I'm going to use that lower end angle. So my theta is 3 pi over 2, and so when I'm done, I can write that in r comma theta form, so my answer is 2 comma 3 pi over 2. So let's run through that one more time with our next one. I'm going to do the math there. Again, a couple people get weirded out when I have to do this negative 2 times the square root of 3 squared. Just keep in mind that you're going to square the negative 2, that would give me 4, and then square the negative 3, that would give me 3, and so 4 times 3 is 12, plus the negative 2 squared that we did earlier. So then this is r equals the square root of 16, and r in this case is going to be 4. Again, it could be plus and minus 4, but I just want to use it with 4 right now for what I'm doing. Then I'm going to go and figure out my tangent inverse. Now we'll use some negative radiuses or radii later, but right now let's keep it positive just for what we're working in consistencies purposes. So now I'm going to simplify this. Theta is the tangent inverse of the square root of 3 when I cancel out the negatives and the 2's. So I'm trying to figure out when the tangent is the square root of 3. Well, that happens when I put the square root of 3 over 2 over 1/2. It should look familiar. This happens in the pi over 3 family, and the tangent is positive in the first quadrant. And so I need the first quadrant and the third quadrant pi over 3 family. So my theta could be pi over 3 or 4 pi over 3. And now again, I have to figure out which one. So I go back to the original point and I take a look at that. Well, this particular point is in the third quadrant, and therefore I'm going to use the third quadrant angle. So 4 pi over 3 is the one that I'm interested in. So my final answer for that one in polar form is a radius of 4 and an angle of 4 pi over 3 that gets me into the third quadrant. Well, today we're going to go the other direction. We're going to convert from polar to rectangular, and we use a couple of formulas for that as well. So I'm going to draw my right triangle that we've used in the past and put my theta in, label my x as the horizontal, my y as the vertical, and r is my hypotenuse. And we've seen this picture before. We're going to look back at SOHCAHTOA, And what I want to do is set up some equations that include x and r and theta and y and r and theta. And so to include x with r and theta, I would have to do the cosine of theta equals the adjacent over the hypotenuse. And if I solve for x, because that's what I want to find, I get r cosine theta equals x. And that's going to be the formula that we use to find our x coordinate. Now I want to go through the same concept, but this time with my y. And so if I want to include y and theta and r, because I'm going to be given theta and r, or r and theta, and I want to be able to find y from that, so I want to only include y and theta and r. And so I would use the sine of theta equals the opposite over the hypotenuse. And again, when I solve, my r times the sine of theta will be y. So again, I'm going to go ahead and take those formulas and use them. My polar coordinates come in r comma theta form, and x is r times the cosine of theta. And so my x is 2 times cosine of pi over 3 is 1/2. Remember, pi over 3 family, the x coordinate. So x is 1. Go through the same process for y. Y is r sine theta. And so my y is 2 times the square root of 3 over 2. When I do my simplifying, I get just the square root of 3. So my polar coordinate gets converted into a rectangular coordinate that is 1 comma the square root of 3. I always think converting from polar to rectangular is a little easier than doing the other way, only because I don't have to think about where I am landing. The angle will take care of that itself. It'll put you in the right quadrant, so I don't have to necessarily think about the signs other than when I'm trying to figure out that value. So pi over 3 was a first quadrant value, which means both of my values are going to be positive. But when I get into this next one, 11 pi over 6, I know 11 pi over 6 is a fourth quadrant value, so my cosine will be positive, but my sine will be negative. And that'll work itself out as we solve. So I'm going to, again, plug that into my little formula for x. X is 3 cosine 11 pi over 6. So x is 3 times the cosine of 11 pi over 6 is the square root of 3 over 2. So x is 3 times the square root of 3 over 2, and I'll just leave it in that form. It's a fine answer. Not a real pretty one, but it's fine. It serves its purpose for us, so I don't need to do anything else. I don't want to make it into a decimal. It's as simplified as it's going to be, so I'll just leave it as is. Then I'll find y. Y is 3 sine 11 pi over 6. And so y is 3 times the sine of 11 pi over 6 is a half, but in the fourth quadrant it's negative. So my y is negative 3/2. And so when I write my converted point here, my x is 3 times the square root of 3 over 2, and my y is negative 3/2. What I'd like you to do is pause the video and see if you can figure out 5 and 6. And then when you're done, turn it back on and compare your answers and see how you did. So for number 5, I knew that I was going to end up in the third quadrant, so I knew that both my values had to be negative, and then when I plugged them into the little formula, I got negative 2 times the square root of 2, negative 2 times the square root of 2. For problem number 6, pi, I know where that is. Pi is over here on an axis. And so I know that that's the point negative 1 comma 0. When I plug it into the formula again, I get negative 2 comma 0. Next move is to graph these, take a look at where the graphs are, and then talk about how we can get to the same position by moving in different directions. So when I'm plotting a point, well, the first one, 3, 0, is actually 3 comma 0 pi. They just don't usually write the pi with it. So what that means again is my radius tells me to go out because it's positive. I go out towards the right, so I'm going to go out towards the right to 3, and then I don't move at all. I stay at 0 pi, and so my point lands right on that axis. The angle will tell me my movement. We've done that before. We've graphed angles, and they move us into the different quadrants. And if it's positive, we go counterclockwise, and if it's negative, we go clockwise. And so if I look at problem number 2, it says go out to 2, a radius of 2, and then go backwards pi and a half. So I go out to 2, and I go backwards. I'm just kind of sketching around pi and a half. So that puts me at 2 comma negative 3 pi over 2. It's all about the movement of the angle. Again, when you're working through these, it's a matter of moving your radius in the right direction and moving your angle to the right position. So kind of break it down. For number 9, I look at this 19 pi over 12. That's not a family member, but I can still get there. We've graphed angles or sketched graphs of angles like that before that weren't regular family members. Remember, 12 goes into 19 one whole time. That leaves me with 7/12 pi. So when I think about what that is, that's 1 and a little more of half, more than half of pi. So I'm going to go out to 4, and then I'll go around to 1 and a little more than half a pi to put my point. I don't know if you can see my little thing moving as we work around. Hopefully you can when I'm thinking about going to 1 pi and then a little more than half pi. Because remember, 1 whole pi is halfway around the circle, and then half pi would be a quarter of the way around the circle. So that's the point 4 and 1 7/12 pi. Now let's introduce here a negative radius. All that means, just like the negative angle tells me I move backwards, the negative radius means that I move to the left instead of to the right. So instead of moving to the right 3, I'm going to move to the left 3, and then I'll move backwards pi and a quarter. So just approximate it on your graph as best you can. So again, I move out 3, backwards 1 and 1/4 pi. Puts me in that 4th quadrant. Now you might be thinking, well, I could get to this point moving in a different direction. What if I moved out 3 and backwards pi over 4? I could get to that same location, and that's kind of what we're going to be working on next. The whole thing about that unit circle is I can get to that spot in many, many, many different ways. And so when I think about where 4 pi over 4 is, 4 pi over 4, it's sort of floating in the middle of the 1st quadrant. That moved me to the right 4, and then an angle of pi over 4 up. But I could get to that by going out 4 and moving backwards that amount. And so that would be 1 pi, pi and a half, and another quarter of pi. So pi and a half plus another quarter, or if I just think about as I work around the unit circle, I'm pi over 4 shy, pi over 4 shy of 2 pi in the backwards direction. So this would be negative 7 pi over 4. Now I could also do this by starting on the negative side. Maybe I'm going out for a negative radius. So I'm going to do negative radius, and move in the positive direction. I would go pi and a quarter pi more, so 5 pi over 4. Or I could go out to the negative and move backwards. And then if I move backwards, that would be 3 pi over 4. So I would go negative 4 backwards and 3 pi over 4 over. Again, when I'm making these, these are not the only answers that we could get. You could get multiple answers. In fact, if you were in the class, everybody in class could have 3 different answers and still be right, because it's just moving around that unit circle. What I usually do when I set it up is I'm going to try and write a second positive. I want a positive. I've gotten a positive angle or a positive radius with a positive angle. So I want to do a positive radius with a negative angle, and then I want to do a negative radius with a positive angle and a negative radius with a negative angle. So those are the 3 additional ones that I want to try, every combination that I can have. And so again, where is 3 pi over 2? So out 3 in the positive direction, pi over 2 would be up on the top. If I wanted to go out 3 and backwards, I would go backwards 3 pi over 2. If I wanted to start in the negative direction, negative 3, I would have to go forward 3 pi over 2. Or if I wanted to go in the negative directions and backwards, I could go to negative 3 and then backwards pi over 2. And so those will get me all of my different possible movements throughout the graph. So the last page is just writing all solutions. And when we were solving, remember I have one lap around the unit circle, and I would keep my values within those families, and then there are 3 other family members that we talked about. But remember that I can move infinitely around the unit circle. So if I wanted to graph this first one, 2 pi over 6, I'm landing here. What if I wanted to get to that spot again? Well, all I'd have to do is add 2 pi and get to that spot again, and add 2 pi and get to that spot again and add 2 pi, and I think you get what I'm saying. So if I want to list all solutions would be 2 pi over 6 plus 2 pi k times, where k is an element of the integers. And so it's just as simple as adding 2 pi over and over and over again, or moving backwards and subtracting 2 pi. But that would be all of the possible points that we could have here. Now, I could give a negative variation of that, but really this is all we need, so we'll stop at that. So again, here, if I'm graphing 4 pi over 3, 4 pi over 3, that puts me in the third quadrant. That's 4 pi over 3. And again, if I want to get there again, I just add 2 pi, and I add 2 pi, and I add 2 pi, and I add that repeatedly. So I don't think I need to go over the last 2 of that, because I think it's fairly simple. We're just adding that 2 pi to get all the rest of the values. Your job is to do 6-2 homework, evens or odds. Keep in mind that your review answers will be posted, and you should be working on your review tomorrow, and then your final will be the next day that you come to class. So if you have any questions, please make sure you let me know, and I hope all goes well.